Hello dear students, how are you? I hope you are doing good. This video is an assistant to our online classes, and as you know that chapter 3A is going on. In this lecture I will discuss with you friction and the associated terms. So let us start. What is friction? Friction is a force which opposes the relative motion. We observe friction in our daily routine life, day-to-day life. If we slide some object on ground or if we throw some ball, we all know that it will come in rest after some time. There is an opposing force which is working on it. If on level plane, if you are having a ball or any object and if it is moving, we know that after covering some distance, this object will stop. And by Newton's second law of motion, we know that F is equal to dp by dt. If this body is having change in its momentum, so there must be some force which is working on it for changing its momentum. Even if you will go by definition of Newton's first law of motion, if a body is in motion, it continue to be in state of motion, or if a body is in rest, it will continue to be in state of rest until unless any external force is applied. So if this object is coming to rest, one thing is for sure, there is some force which is acting on it. In this case, this force is force of friction, which always works in the direction opposite to the direction of motion, which makes it to come in rest after some time. Let us understand why friction is there, what is the origin of friction. Dear students, we are having two views regarding this. One is classical view and another is modern view. According to classical view, if we observe an object placed on the surface of other, what we see? We see that the surfaces are smooth. But if you will magnify this view under a microscope, you will observe that the two surfaces which appear smooth are not that smooth and they are quite rough. There are wedges and grooves. These wedges and grooves of object interlocks with the object below on the surface, and as one surface tries to move over another, these wedges and grooves, they create friction, they create resistance in motion. That is the cause of friction according to classical view. But this classical view is not able to answer the question, what happens if we make surface smooth? So here is one interesting point. If surfaces are rough, we know that friction is more. If surface is smooth, friction is less. Friction reduces. But to your interest, let me share you one fact. If we make the things extra smooth, friction increases. Yes, if we make the object surface extra smooth, friction increases. So I can take an example of mobile phone, very common object. You can see this mobile surface, this surface is very smooth. If I am holding this surface like this, then if I am tilting it, then force of friction is working and this mobile is not going down. With increase in angle, the component of gravity will increase and mobile must go down. But you can observe that up to very good angle, look how deep it is, almost vertical, then only mobile slides to be done. So what is happening? With extra smooth surface, friction is increasing. So this classical view cannot explain this thing, that with extra smooth surface how friction can be increased. For understanding this point, the modern view comes in focus. According to modern view, friction is not due to those wedges and grooves which get interlocked into each other. Friction is there due to intermolecular attraction of two different materials when they are moving over each other, or the same, even if the object and surface are of same type, then also friction is there. So modern view is simple. According to modern view, friction is there because of interatomic interaction of two materials which are moving one over the other. So that is our modern view. I hope you get this point. Next point we are having in modern view, as we can see, due to but rough surfaces are still there, surfaces are not that smooth, and the actual points of contacts are very less comparing to the apparent area. If this is the apparent area of contact, then actual contact is at very few points. These dots which I am representing, they are the actual area of contact. So on this actual area of contact, pressure is very high. And at these point, the molecules of A object comes very close with the surface of B, and at these points pressure is so high that these points almost they are in so much close contact that force of attraction is much higher, and they are almost cold welded, they are welded to each other. And if you want to move object A over the surface of B, you have to break through those weldings, and that is known as cold welding. So these points are known as cold welded points. So according to modern view, when you are sliding one object over another, due to intermolecular attraction and very small actual area of contact, the surfaces becomes cold welded with each other, and when you are moving them, you have to break those weldings. That's why friction is there. So these are the two views about origin of friction, that from where friction is coming. And it is also clear from this, doesn't matter you will move it on left or you will move it on right, friction is always there. So friction will always work in opposite direction. Next point we are having one more small discussion here: external friction and internal friction. When we are studying friction in solids, like when one solid object is moving or sliding over a surface between solids, like A and B both are solid surface, and force of friction is there at the interface of these two objects. One is the object, other is the surface, and friction is working here between two different objects, between solids. Then this is known as external friction. On the other hand, we are having internal friction, for which even two different materials are not required. Consider water flowing in a pipe. The innermost layer of water is having maximum velocity as it is in contact with another circular layer of water, and then another layer. So these layers of liquid have friction with each other, and this is a friction which is there in fluids like water or even air, which is also considered as fluid, is known as internal friction. And we are going to study about internal friction in unit 7, properties of matter. For now we are paying attention only on our solid friction. So the next topic is very interesting, that is static, limiting and kinetic friction. And you must understand this. very carefully. So consider a surface on which we are having an object. When this object is at rest, we know that weight is always working downward. Mass of this object is m, and the normal reaction is opposite, that is also equal to mg. Now consider if you apply some small force F here, force of application, then a force of friction will generate in the opposite direction. This force of friction will come into action only when you apply some force Fa. If you don't apply any force, there is no force of friction. Applied force can be increased. With increase in applied force, force of friction will also increase. But there is a limit on a maximum value of force of friction, beyond which force of friction cannot be increased. And only if the applied force becomes greater than force of friction, then the object will actually start moving. तो ये मार्कर जैसे आप देखो कि मेरे हाथ में है, तो अगर मैं इसको मूव करवाने के लिए फोर्स लगाता हूँ, मैंने भी बहुत हल्का सा फोर्स लगाया, ये मार्कर मूव नहीं हो रहा, क्योंकि जितना मैंने फोर्स लगाया उतना ही फोर्स ऑफ फ्रिक्शन आ गया. लेकिन अगर अप्लाइड फोर्स मैं इंक्रीज करता हूँ तो देखो ये मार्कर मूव होना शुरू हो जाता है. यानी कि व्हेन माय अप्लाइड फोर्स इज ग्रेटर देन फोर्स ऑफ फ्रिक्शन और एंड बिलो दैट, अगर मेरा फोर्स अप्लाइड फोर्स ऑफ फ्रिक्शन से कम है, तब तक ये मार्कर जो है, ये मार्कर मूव नहीं करेगा. जब अप्लाइड फोर्स ऑफ फ्रिक्शन से ज़्यादा होगा तो ये मूव करेगा. तो जो हमारा फ्रिक्शन है, जब तक हमारा ऑब्जेक्ट रेस्ट में रहता है, स्टैटिक रहता है, तो उसको हम स्टैटिक फ्रिक्शन कहते हैं. दिस इज योर मोस्ट इंपॉर्टेंट पॉइंट, that static friction is a self-adjusting force. Static friction is a self-adjusting force. You apply force, you increase the magnitude of applied force, force of friction will also increase. So if we'll plot a graph between applied force and force of friction, let me have this force of friction with red color and applied force with blue color, and let us have a graph between force of friction, that is small f, and let Fm be the maximum value of force of friction, and with blue I am having applied force Fa, which can be increased to any value as we want. So when your applied force is 0, your force of friction is 0, so we got one point at origin of this graph. Now as you increased your force of friction, applied force by 1 Newton, force of friction will also increase by 1 Newton, and we get this point, straight line, both 1, so 45 degree. Let us say we again increased applied force to 2 units, then force of friction will also increase to 2 units. We'll get this point, we are getting a line which is at angle of 45 degree. In the same manner, up to the point where applied force is equal to maximum force of friction, you will get this straight line, which is having an angle 45 degree as both the force are equal. What will happen beyond this point when your applied force becomes equal to maximum force of friction? This maximum value is known as limiting friction, limiting force of friction. And if this starting point is O and this point is A, then A point is the limiting friction point, and O to A, not including A, O to A point is known as static friction. So static friction is a self-adjusting force, and it is there up to the point where object is in rest, while A point itself is limiting friction where object is just on the verge of moving. What will happen if you will further increase the force? If we increase the force, then object will come in motion, and for maintaining this object in motion, we need a force which is slightly less than the limiting friction force or the maximum friction force, and that range, let us say this point is B, then the range which is ahead of B is known as kinetic friction. So what you learned in this graph, that till object is at rest, applied force is equal to force of friction, that is known as static friction, to a maximum point which is known as limiting friction. Then after limiting friction, when applied force is equal to limiting force, further if you will increase the applied force, the object will start moving and the friction force decreases slightly, and that is known as kinetic friction. Kinetic friction is slightly less than limiting friction. So this is your graph versus applied force and force of friction. Force of friction will not increase now. After limiting point, it will decrease slightly and will become constant. And now if you will increase the applied force, the acceleration of the object will increase depending on the difference of applied force and the value of kinetic friction. Okay. So next point is sliding friction and rolling friction. So till so far we were discussing that when one object is made to slide over the other object, that is known as sliding friction, and we have been studying about static, limiting and kinetic friction in case of sliding friction. We know that sliding is not taking place every time. If you are having a wheel which is moving on some surface, then sliding is not taking place. Sliding will take place only if you will apply brakes and a skid is going on, that is sliding, but otherwise wheel is rolling. Wheel is not skidding or slipping over the ground. Slipping and slipping came under category of sliding friction. So sliding friction we have already discussed. What is this rolling friction and uh, how it is different from sliding friction? In rolling friction, the surface which is coming in contact with the ground is apparently at rest. It is not moving. The next point will come. It will gently touch the ground and will go up. Then from where friction will come? If you will observe minutely, the area of contact of a circle or a sphere is theoretically a point only, but practically this is some area, and below that area pressure is very high. So the surface below that round spherical or circular object will create a depression here, and this depression will make the surface below the wheel at little lower level than comparing to the remaining of the surface. So in a nutshell, what the concept of physics is telling you, whenever you are having a solid ball, a sphere, a wheel or a ring, whatever, and you are just rolling it on the ground, what you are doing in actually why that coming to rest, that surface is in contact with the ground at very small contact area, and at that very small contact area the pressure is very large. So the ground below that circle goes little down and creates a depression there, and when object is moving, object is actually coming out of that pit. वो उस नीचे वाले पोर्शन से ऊपर आता जा रहा है हमेशा आपका ऑब्जेक्ट जब चलता जा रहा है। तो इसका मतलब ये है कि वो थोड़े से उस हाइट डिफरेंस की वजह से, जो ये थोड़ा सा हाइट डिफरेंस होएगा, जो राउंड ऑब्जेक्ट के नीचे वाला ग्राउंड दब गया और बाकी ग्राउंड ऊपर है, जब आप इसको मूव कर रहे हैं तो ये हमेशा ऊपर आ रहा है थोड़ा सा, और ऊपर जब आना पड़ेगा तो अगेंस्ट ग्रेविटी, वी नो दैट W इज इक्वल टू mgh पोटेंशियल एनर्जी का फार्मूला है, इसको काम करना पड़ेगा ना, ये हमेशा हाइट चढ़ रहा है और ये हाइट चढ़ने के लिए एनर्जी कंज्यूम होएगी, और वो एनर्जी जो कंज्यूम हो रही है उसकी वजह से फ्रिक्शन डेवलप होएगा और वो एनर्जी रिस्पॉन्सिबल होएगी इस ऑब्जेक्ट को रोकने के लिए। तो दैट्स व्हाई देयर इज फ्रिक्शन इन रोलिंग एंड दैट इज द cause of rolling friction. So that's why it doesn't matter sliding or rolling, object will eventually come to a rest after some time, even though the friction force in sliding is more than friction force in rolling. In rolling, friction force is less. That's why rolling object will come in rest much later comparing to a sliding object, because of same mass and same material and same surface. Your rolling will come a rolling object will come to rest much later because rolling friction is much less than sliding friction.